In this video, I'm going to explain the law of sines, then I'll do number 5 and number 8 from the homework assignment so that you can get an idea on how to find a missing side length and then a missing angle using the law of sines. So the law of sines and cosines, which is what we're working on this week, expands trigonometry from right triangles to any triangle. And so it really allows us to do a lot more. The law of sines is also known as the sine rule. And like I said, this applies to all triangles, okay? And so what we've got going on here is the sine rule is the sine of angle A over side length A is equal to the sine of angle B over side length B, which is equal to the sine of angle C over side length C. And so we have a ratio again. And so this is why we started first with similarity and moving on, because we can see these commonalities. But always we want to remember that if you focus on two of these, you have a proportion. And so when we're solving, you solve just like a proportion. You can cross multiply, you can multiply by the denominators, you multiply by the inverses, all those things, reciprocals. Okay, so what are each of these representing? So this is in a triangle. So again, non-right. We have triangle A, B, C. Now, the capital letters represent the angles because at the vertex of an angle, we have a point. And we learned all the way back in chapter 1 that points are named with capital letters. And then opposite of angle A is side length A, opposite of angle B is side length B, and opposite of angle C is side length C. So why are they named this way? It all has to do with its corresponding part. So angle A and side length A are directly related. If we were to open this angle up, rotate it further apart, and this side were to go over here, side length A would become longer. Side length B and C don't need to change, but side length A would be affected. If angle B were to, say, become closer together, smaller, side length A and C could stay the same, but side length B would be affected. Same thing with C. If we were to alter this angle, if it goes bigger or smaller, side length A and B could stay the same, but C would be affected. And so that's how we get the angle and its opposite side that are matching together. So how did they come up with this ratio anyways? So what they did is they went back to the trig ratios. But in order to look at the trig ratios, we have to have a right triangle. And so in any triangle, you can always draw in an altitude. An altitude goes from a vertex and it meets the opposite side at 90 degrees. We're going to call this the height. That is the height. And so when we do that, we separate this triangle into two right triangles. One where angle A remains whole and the other where angle C remains whole. So when we focus on this right triangle with angle A, this side length, we don't know what it is because it was side length B cut into two parts, but we don't know how. And so we don't know the adjacent leg, but we do know that the opposite leg is the height and the hypotenuse is C. So if we know opposite and hypotenuse, that is so. We're dealing with the sine ratio. So from this triangle over here on the left, we have sine, my pen is running out, sine of angle A is equal to opposite, which is the height, over the hypotenuse, which is side length C. Okay, now let's focus on this right triangle on the right. Okay, our angle that is a part of the original triangle, do you see how angle B is separated into two parts? So it's no longer angle B. This would be angle CB, D, and ABD, and then angle ABC, right? Multiple angles, multiple letters. So we no longer are dealing with angle B anymore because we've broken it up into two parts. And so here the whole angle would be angle C, its opposite leg would be h, and its hypotenuse would be a. So we're dealing with opposite leg and the hypotenuse. So again, it's the sine ratio. So we have sine of angle C is equal to opposite, which is the height, over its hypotenuse, which is side length A. So once we've set up these two, we see that these two equations have something in common, the height. And so I'm going to solve for h. In the equation on the left, h is being divided by c. I want to do the inverse of division, which is multiplication. So I multiply both sides by c. We get c times the sine of angle A is equal to the height, right? These have canceled. And so on the equation to the right, we have h divided by a. We want to do the inverse of division, which is multiplication. So we multiply both sides by a. We get a times the sine of angle C is equal to h, because these canceled. And so now we have h equals two different things. Well, I know that these h's represent the same line. So we have h is equal to h by that reflexive property. Anything is equal or congruent to itself. Now this h refers to this, right? We've got c times the sine of angle A. And this h refers to this h, which is a times the sine of angle C. And here, if I want to get sine of angle A by itself, I'm going to divide both sides by C. So this cancels. So we have sine of angle A is equal to A times the sine of angle C over C. And then if I want to get rid of A on this side, I divide because it's being multiplied. So we put it in the denominator. What I do to one side, I do to the other. So that cancels over there. And we get sine of A over A equals sine of angle C over C. And that's one step. Right now in this ratio, what we're missing is B. So if I wanted to do that, all I would do is turn my triangle and draw in a different height so that we would create two right triangles where B is a whole angle. And we would do it again because remember there are 3 different heights in every triangle. And so that's what we would focus on. So anyways, that's how it is created. So through the same logic, we can also find that sine of angle B over B is going to follow suit in with that. And so let's take a look at number 5 from the homework assignment. This is on page 657. So that we can take a look at how to find a side length. So how do we know that we're using the law of sine? Well, we are given 2 angles and 2 side lengths. So if we're thinking about the ratio, right, this deals with 2 angles and 2 side lengths, right? If we think about just focusing on a proportion, not all 3, but just 2 at a time. And so if the 4 parts that we're dealing with are 2 angles and 2 sides, this is going to work. So 2 angles, 2 sides. Now the important thing is, are the angles and sides across from each other? So if we take a look here, 79 degrees is across from W, so this would be angle A, this would be side length A. And then 52 degrees is across from 28, so this would be sine of 52 degrees, or this would be angle B and this would be side length B. If we look at number 7, so just want to scroll over to number 7. This one's a little bit different. We have 2 angles and 2 sides. So right off the bat, I'm thinking, okay, I'm going to use the law of sines. The main problem here, though, is we don't have opposites. So if we have 87 degrees here and 41, that's an opposite. So sine of angle A over side length A. But here, sine of angle B over side length B, I don't have that or want it. What I do want is this length Y right here. So what I need is its angle opposite. what we need to remember is that the three angles of a triangle always add up to 180 degrees. So I would use triangle sum to find the measure of the angle opposite the side I want. So I would do 180 minus 87. So that's going to get me to 93. And then I would do 93 minus 46. And that would give us the angle over there that we would use as our ratio. If you want me to do number 7, all you have to do is request it. Okay, so let's take a look back at number 5. So we have sine of angle A over side length A is equal to sine of angle B over side length B. And in the video, they talked about you can flip the ratios and still have it be equivalent. Oh, you can't see that. And that is completely true. If that feels confusing, don't do it that way. You can always go with the original and cross multiply. I can go over it a different way. All you have to do is request it. So we always want to match up our opposites. So if I start with 52 degrees as my angle A, 28 has to be my side length. So we have sine of 52 degrees over 28 is equal to sine of angle B, so that's the second angle, 79 degrees, over its opposite side length, which is W. So this is one of the reasons why they talked about doing it the other way, like if you were to flip it, is if we were to flip it and have W in the numerator, it'd be very easy to get W by itself. Here, when W is in the denominator, I'd have to multiply both sides by W and then divide and all that. So the easiest way to do this is just that cross multiplication. And so I have W times the sine of 52 degrees is equal to 28 times the sine of 79 degrees. And I want to get W by itself. So W is being multiplied by the sine of 52. Now, the sine of 52, remember that this becomes a ratio, right, when we plug it into a calculator. And a ratio is a number. So this right now is just a number that we don't quite know yet, right? We have to wait till we plug it into the calculator. I do not want you to plug it into the calculator till the very end because the ratio is going to be a decimal that goes on for a while and we don't want to round. We always want our answers to be as accurate as possible. So to get W by itself, I want to divide by the number it's being multiplied by, which is sine of 52 degrees. What I do to one side, I do to the other, sine of 52 degrees. So this number over this number becomes the number 1 because they're the same. And so we have W equals, and this whole thing, 28 times the sine of 79 degrees divided by the sine of 52 degrees. And so what I'm going to do is in my calculator, and again, I don't have one of the school calculators, I have my phone. Sorry if you guys can hear the lawnmower. Clear. So we've got the sine of, trying to get a way so you guys can see this. Okay. So what are we plugging in? We are plugging in 79 degrees. So here's 79 degrees. And then we want to take sine. So I had been doing a previous problem with the inverse, so I want to make sure that I'm back at sine by pressing the second button. And we press sine. So there's our decimal. And so we're multiplying by 28. So I'm going to do times 28. And I'm going to press enter. So this is my numerator, and this is one of the reasons why we don't want to write it down is because see how far it goes? We don't want to round that. We want it to be as accurate as possible. So I'm going to take that value and I'm going to divide by my denominator. So I need to input the degree first, which is 52. Do not press enter because what we want to do to the 52 degrees is take the sine of it. So this is now my denominator, and now I press equals, and we get 34.87. The directions say find each length to the nearest centimeter. So the 34.8, the 8 tells the 4 to round up. So we get W is about 35 centimeters. Okay, I'm going to go close the window really fast. Okay. Now I'm going to go ahead and do number 8. So number 8, we want to find the measure of angle A. And so here, again, we want to take a look at our angles and opposite sides. So we have sine of angle A over side length A. So again, this is number 8. So sine of angle A over side length A equals sine of, we have angle C. So sine of angle C over side length C. So here's angle A, here's side length A. So we have sine of angle A, our unknown, over 36 is equal to sine of angle C, which is 42 degrees, over side length C, which is opposite, that's 29. And like I said, it's a ratio, so we can go ahead and cross multiply. Okay, so here we have 29 times the sine of angle A, which is our unknown. And here we have 36 times the sine of 42 degrees. To get the sine of angle A by itself, we want to undo the multiplication, so we're going to divide by 29. And so we get sine of angle A is equal to 36 times the sine of 42 degrees over 29. And you can see I left this little gap here because I can foresee that I need to take the sine inverse to undo sine. So we're going to do sine inverse. And what we do to one side, we do to the other. So sine inverse and sine cancel, leaving the measure of angle A by itself. And then we want to do sine inverse of this whole thing. So remember that in the calculator, we want to get the ratio. This is the ratio. We want to get that first and then apply the sine inverse button. So let's go through how to do that. So I'm going to open up my calculator on my phone. I'm going to clear what we did before. And so here's my numerator. So we're going to do the 42 degrees first, so 42. And then I'm going to press the sine button. So that is the ratio of sine of 42 degrees. We're going to multiply by 36. And that's my numerator. And then I'm going to divide by 29. Okay, so this is the decimal inside of that parentheses right here. So now I'm going to take that ratio that I got, right, which is 0.83, and I'm going to apply the sine inverse. So right now I need to press the second button so that we see sine inverse. I'm going to press sine inverse, and I get 56.16, and I bet it's going to say round to the nearest whole. Yes, round to the nearest degree. And so 56.1, the 1 tells the 6 to say the same, so we get 56 degrees. I hope this was helpful. If you need any other clarifying information, just please go ahead and write it on the Padlet. The more descriptive you are in your questions, the more guided I can be in my videos. So if you just say, I don't understand, if there's something specific that you want me to address, please make sure you write that there. Otherwise, I'm just going to kind of navigate in what I am guessing you need. So again, if you don't want me to guess, just please be a little bit more descriptive. And I thank you very much for asking questions.